I am totally delighted, honored, overjoyed to be coming to MIT. I think it's just a fantastic opportunity for me to connect with some of the most amazing students and colleagues that I've ever seen. So, one of the main things I do is to study how a broad range of chemicals contributes to climate change. So not just carbon dioxide, although carbon dioxide too, of course. To me, it's one of the most interesting chemicals, but it's not the only one that's actually contributing to the way our climate is changing. So I'm doing work on everything from aerosol particles in the stratosphere to water vapor to different kinds of industrial chemicals like hydrofluorocarbons and perfluorocarbons. I'm a chemist by training, and I'm absolutely fascinated by anything that affects the chemistry of our atmosphere or its climate. I'm also continuing to work on stratospheric ozone. There's a number of different issues there that, from a scientific point of view, remain tremendously fascinating and still interesting questions for the community to address that really have to do with some of the real details of the mechanisms of the chemistry that affect the Antarctic and the Arctic stratosphere in particular. So I'm having a ball, pole to pole, surface to stratosphere, climate to ozone. I absolutely love ranging over that whole chemistry space. I am very excited by the fact that students today are an exceptional breed of cats. They really are deeply interested in how science connects to the broader society in a way that I think I didn't see 10 to 15 years ago. I'm not sure what all the social factors are that have contributed to that, but I think we have a remarkable generation of young scientists coming up, and engineers too, I should add. So I'm very, very interested in trying to help them understand the things that they want to know about how science and engineering has connected to society in the past and how it can do so in the future. So what I really want to do is to try to teach environmental studies in a much more holistic way, where on a case study basis, looking at issues like ozone depletion and the Clean Air Act and even going into hopefully eventually some biological issues such as sustainable fisheries, we can really talk about the science, but we can also discuss the ways in which the science was communicated to the public, the ways in which policy reacted to that information and to the public opinion, and very, very important, the ways in which engineering and innovation actually contributed collectively to solving a broad range of environmental problems. We've had 50 years of just remarkable success, I think, in dealing with a whole host of environmental problems. And I want to explore with students the reasons why those successes happened, looking really for the common threads of what it takes to successfully address an environmental problem. In a lot of cases, we don't solve the problem, we just figure out how we're going to manage the problem. What are all the factors that actually entered in the history of what we've done in the past, and how do they compare to the things we're doing now? And how are the things that we're doing now influenced by the fact that we are different? Society today is facing some tremendous challenges, particularly in terms of development, and you can certainly use the word sustainable development for a whole host of people on this planet who are getting access to many things that they never had before. Billions of people in the developing world are beginning to enjoy some of the same benefits that we in the developed world have enjoyed for a long time, and the stresses on the system that are coming out of that are clearly enormous. I think it's a tremendous time to look back on how we succeeded in the past, how we in our very, very challenging period of human development are going to succeed in the future. And I'm an optimist. I know we're going to succeed. Climate science is certainly one of the most important challenges that humanity has ever faced. Climate change, whichever way it comes out, whether it turns out to be something that we manage wisely or unwisely or whatever, I think it's quite clear that the planet in the next 20 to 40 years is going to change in ways that we haven't even really thought about. And we're constantly turning the corner and being confronted with new ways in which climate change is manifesting itself, and whether that's acidification of the ocean and what it may do to various different kinds of organisms, or what it does to, say, insects and the way that they interact with forests, things like the mountain pine beetle, which is ravaging the forests of the West and in Canada. All those sorts of questions. How much are these things changing? How much of that change is human-induced? What is it going to do in the future? These are epic questions. And I find it very, very exciting from a scientific point of view that we're standing on the threshold of a different planet. It's going to happen in our lifetime. So what better thing for a young scientist to pick than an area of science that is about to explode? It's just a great time to be doing climate science, in my opinion.